if you're buying Bitcoin, but you can't take custody of it, is it Bitcoin? That's what
Yeah,
like.
it's just price suppression, straight up.
Well, that's
Cause yeah.
I've got my meetup this Thursday. Shenandoah Bitcoin.club is the website for anybody happens to be watching or paying attention. But yeah, I'm anticipating. I've had a lot of interest. We'll see if people actually show up, but I'm anticipating a
Nice.
lot of questions around like FTX and like all this like crypto blow up stuff and um, yeah. But on the flip side of that, I've got a group of former coworkers from my time in the military that they're all Bitcoin. They're like, let's do this. Well, the one
Okay.
guy is trading derivatives like shorts and longs and stuff, and like trying to whatever. So
Mm-hmm.
we're getting him to come around. But yeah, everybody else is down, and then
Do something productive instead, and just saving Bitcoin.
right,
Yeah.
yeah. So it's pretty interesting. And then one of the guys locally around here, he's just super busy, so he can't make it out to the meetups. But like I've got him down the rabbit hole, and he texts me like periodically. He's like, "Hey, have you seen this?" I'm like, "Yes." Well, he follows me on Twitter too, so maybe he's watching. Hi, Stu. But yeah,
Says too.
he like gets it. Like I see him at the gym and stuff. That's where I met him, and
Mm-hmm.
yeah, he gets the whole thing. He's like, "Yeah, it's a fixed supply. Once you have a percentage of it, I don't know if he's gone deep on the technicals, but
Yeah.
he understands the principles of it, and he's about it. I don't know
Nice.
how much he's buying, but I'm pretty sure he's buying.
Yeah, I downloaded today let me just pull up his name.
Did you
The
download
educational account. Anil said so. I don't know if you're familiar with him.
the
He's got
Orange
these
Pill app?
visuals. Anil, like Anil, said so.
Let's check it out. Let's pull up Twitter. Pull up my Twitter on
Yeah.
live stream.
Anil, then said so, like he said so.
Ah,
He's got like these visuals for teaching Bitcoin, like on his website. If you go to the Gumroad
oh,
website,
yeah,
yeah, like this kind of stuff.
huh.
And one of the things he emphasizes in the materials is that there is the economic side and the technology side, like the monetary and the network side.
Yeah, yeah, yeah. Interesting.
And not everybody needs to know all the aspects, right?
Yeah, yeah, yeah. See, I've been following this guy, and I'm actually one day, hopefully, I get around to working on the dev side of it. But I feel like I need to do this first. Feel like I need to get the Bitcoin fundamentals down from a technical perspective. And I'm sure I
Mm,
don't need to, but it just feels right. Pedro, I don't know if you've seen. That's a very generic name. Pedro MBPG.
no, not familiar with him.
So he's got some. He's a design guy too.
Nice.
Um,
Those are important.
right? Yeah, and he's got this Sat Signer app. Let me see if there's. Oh yeah, he did Bitcoin for local business. I don't know if you've seen these. These are fantastic little like brochures to print out
Mm,
and give. Um, but he designed them all. And then there's man, where's that? Oh, I can just show you the website.
following him now.
Yeah, yeah, follow him.
Nice.
But he's got this vision for an app that sort of like walks you through all of these. Um, like it's much more explicit than some of these apps are, where like it doesn't hide things from you. It
Hmm.
shows you what it is, sort of thing. Um, so
Nice.
like these,
Oh,
the
that's beautiful.
UTXOs are like shaped, right, and they're relatively big compared to one another, etc.
Mm-hmm.
Sign and send, right? Instead of like a transaction, no, you're signing and sending something because that's what you're doing to move the coin. Is you're signing a message that says move the coin from A to B, and here's my cryptographic signature.
Uh,
Um, yeah, just
and
all
you
kinds of
learn
very
and you
interesting
learn while
visuals.
doing it.
Yeah, yeah. It's not. It's like I said. It's not trying to hide it from you. It's like um, I saw it as a wallet for a Bitcoiner, like for somebody that's like, hey, I want to learn Bitcoin.
Mm-hmm. That's awesome.
So
Sat signer.
SadSigner, man, sadsigner.com. There's a Twitter handle for it. Um, so yeah, and I guess he's trying to get a
Funny.
film. Yeah. So the dude's doing some work for sure. Like he's not super active on Twitter necessarily, but like it's because he's putting in work, from what I can tell. But I know nothing. Don't trust me. Go verify.
I know, this seems great. The Anatomy of Bitcoin, that's a film, right?
Probably. Yeah, it looked like it. Um. All right. What What are we talking about today? Where do we leave off? Did you want to do a recap, or should I?
You want to start with the recap and I'll
Sure,
tag
sure, sure.
along?
Yeah, yeah, yeah. So I think. Oh, you know, it'd be cool. Let me see if this works out the way I think it will. We can pull up the Git log and look at what we
Mm.
did. So like we were working on, and I just committed this today because I forgot to before we signed off. Um,
Mm.
but we were working on elliptic curves specifically last session, and the point math that went into that. And we didn't quite finish addition because there were some like uh, cases in
Mm-hmm.
elliptic curve addition or arithmetic in general that needed to be handled. We found out there's an infinity for a float 64 in Rust. And then, yeah, we use that infinity because that's kind of applicable for
Did
these.
we did we run the tests for Infinity? Did I don't recall
We did.
if they all went through. We did, right?
We ran I mean, we'll run them again. See what happens.
Because using Infinity as opposed to null or none.
Right, right, right.
Is Rust no or none?
There
There
is no
isn't
null.
such
There
a
is
thing.
no none. There is. Yeah. It's. I think it's. Is it option or what is it? Yeah.
Nullable.
So it's either. Okay. I'm sorry. There is a none,
Hmm.
but
Okay.
it's based on an option. Option is like the type, where you have
Mm.
like you either have some or you have none. But it's
Oh.
not. But what it does is Rust forces you to handle um, both cases, if that makes sense. So like you have to. You'll see this matching pattern, like pattern matching, very like a lot in the Rust world. It's very very common, especially when you have options.
Mm.
And so you're basically saying like, hey, when there's some, like when there's something there, do a thing, right? Like, and then you can make
Mm.
this function code, whatever. If there's none, do this other thing. Um, and yeah, you have to explicitly code that, how you handle each of those scenarios.
Mm.
And sometimes it's just like, okay, I just want to panic here. And panic's kind of like how you crash the program in Rust. But it's very that's one of the I don't want to say, yeah, I guess it's a benefit. It's one of the benefits or one of the things that they intentionally designed Rust to do was have this sort of like safety guarantees where um, because you have to explicitly handle the case where there is something or there is nothing, you avoid something called a null pointer exception. Have you heard of that, or NPE?
No.
So null pointer exception is essentially when you reference you try to create a pointer, right, to somewhere in memory that is just null, like there's nothing there.
Mm-hmm.
So you see this in some of the other languages. So I work in Java, like in my day job. So for instance, if I have an address, right, with like address line, city, state, zip, and if I call address dot get city, right, to access the city of that address, but address doesn't exist, it will throw a null pointer exception saying you can't call get city on null, like it doesn't, like there's nothing there, like it doesn't work. um, and there's whole, like, I'm sure there's probably like dissertations around null because um, the guy that like I think invented it, or like some dude that had something to do with the original like null. There's like a whole article about like it's the $1 billion mistake, meaning so much software has been like buggy or crashed because of a null pointer exception or some sort of null
Um,
reference that caused issues. Because from my understanding, and I don't think I've ever encountered this myself, but I think in some of the lower level languages like C and C++, it can be very tricky to diagnose and troubleshoot this, um, a null pointer
Interesting.
exception. But yeah, I've never written in those language, so
When you're referencing key value pairs and you reference a key that doesn't exist, is that some sort of no pointer exception?
so that's a good question. So yeah, if you look at like a hash map, right? So a hash map has like key values.
Mm-hmm.
Um, let's see, right? So like, let me see here. Yeah. So insert. Where is insert? So insert takes in the key and then the value, and it
Mm-hmm.
returns an option, right? And that's where we go back to that option code in Rust, where it's like, hey, it's either you either have something or you don't when you actually go to get it. So, and I think what is it called in here? Yeah, get. Okay, that's easy enough. So the get function is it returns a reference to the corresponding key. Obviously, if there's no key, you're just going to get none,
Mm.
right? So like here, so there's a map. We create a map. We insert a under the key of 1, and so when we get 1, like by that key, we have some, right? When we get
Mm-hmm.
2, there's none because there's nothing there. So it's like if you get something, like the return type of this get function is an option. So you can't do anything
Mm.
with that option unless you handle that option first, if that makes sense. Which there's a way to.
Ah,
So
so something I get on Python quite often that the key doesn't exist and it crashes the program.
yeah,
Like on Rust, you have to handle that.
yeah. You're
Otherwise, you can't compile it
so
if you're not handling the option.
even if you do, but so there's also the option to just not handle it, right? Where this is like, um, so there's you'll see this unwrap around here sometimes, where it's like if people are hacking things together just quickly, and I think we probably have unwrap in our code somewhere. Um, nope, we
Mm.
don't. But
We did use maybe with a different
yeah, that's what I
function.
was thinking. Yeah, we do. And so basically, it's like a way of saying like just give me, just like trust me, like there's something there,
Mm.
so just give me it. And it's a way like if you start getting some of these errors where like things are not working or whatever, it crashes or panics, you can start looking for those unwrap points and then kind of like refactoring it to actually handle the option as opposed to
Mm.
just kind of cowboy coding like okay I know there's something here because it's like 3 lines of code, so it's just like give me the value please.
But if you don't rely, like if you're not in a hurry and you don't want to use any unwraps, like Rust is gonna make you handle all of these exceptions.
Yeah, because you can't do anything
Compile.
else with an option, like you can't get the value within the option without handling it,
Oh,
right?
interesting.
Because if you're returning when we look at this get, the return type of it is an option of type v, which is the type of value, right? So it's like getting the value itself
Mm-hmm.
using the k, which is like the key.
Okay,
um,
yeah.
and so because you're getting an option back, like that's the type that you have when you're done with that. And so the only thing you can do with an option are like all of these methods here, but for the most part these are all kind of like handling those cases.
Nice. And you have to handle the none and the sum.
Yeah, and yeah, it all depends on how you handle it.
Mm.
And
Okay.
it's like yeah, you can handle it different ways, but it like you have to handle it. You can't just if I do a get for a value and the value I get back is an address, um, it wouldn't be an address, it would be an option of address. and then before I can do address dot
Mm.
get city or whatever, I would have to unwrap that or handle, does it exist or not, sort of thing. And it's sort of like a
Okay.
safety. It forces you to consider that, and like I said, you can explicitly unwrap it, and then you just kind of like neglecting it right then and there. Um, but it is a conscious thing for you to just like type the code.
Mm-hmm.
So,
That's very cool.
yeah. Um, so we did part of the addition, and so I think we were, let's see here, down beyond elliptic curves, point addition. I think this is it here.
Little theorem. Deriving the point addition formula.
Yeah. Yeah, so I think this is, oh
Maybe we
yeah.
could do, yeah, we could do exercise 4. I don't think we have done it already, have we?
I don't think so.
We're,
So
I think we
handle
did
the,
exercise 3, I remember now.
right, yeah, because that point returns infinity. We could probably label
Wait.
these.
Mm-hmm. Oh, yeah. Can you send me the live
Oh,
share link?
yes. I'm so sorry. I will send it via Discord.
Okay. Yeah. I don't want all the internet join your session.
Not tonight, no. Maybe some other day.
I have so many VS Code windows open, by the way.
Oh yeah?
5, 6. Yeah,
Working on all your stack chain work, yeah?
exactly.
Dude, that's great to work. So, and that's what I love about the Bitcoin scene is like, it's like people are working on all these other little crazy things, and it's just, yeah. I'm sure there's so many people that have helped you too. Like, oh, what are
Mm-hmm.
you working on?
Yeah, no, there's 2 like professional Python developers that I can ask a few questions.
Yeah, there you
My
go, man.
Python journey
Everybody's on the mission.
that helps, yeah. But I'm chugging along a lot on my own. Like it's incredible how much you can do with just Stack Exchange,
It's
right? Stack
free.
Overflow, man.
It's free. I mean, I taught myself coding, and it's like there's all these resources out there. Like, just go learn. Like, if you are
Mm-hmm.
intellectually curious, and I think that's the biggest thing that a lot of people lack, is they're just not curious. Like
Yeah.
some people just don't. I don't know. Like, there's an itch I scratch when I'm like learning something.
Mm-hmm.
So,
Yeah.
uh,
Yeah. Exactly. Yeah. Better go for it because it's all there. Yeah. No need to
yeah.
dump 200K in a CS graduate. Like never care about it.
Right. So these were identity point. Oh, that's what it's called, identity point. So this is exercise 3 that we finished here.
Mm-hmm.
So next would be exercise 4. Okay. Yeah, because we talked, it was a vertical line. That's what the addition was for. And that's the identity point because when you have that elliptic curve thing and like it goes vertical, there's only 2 points that it hits. And so
Mm-hmm.
when those 2 points are added together, it's infinity or the identity point, which is
Yeah.
just,
Yeah, and it was one of. I remember we had to use the clone parameter for the variables. The
oh,
clone
yeah.
copy, right? Derived clone copy,
Yeah.
so they wouldn't be consumed after they were used after each test.
Right. Yep.
Exercise 4. I can write it down here for us.
Yeah, let's see what it is. So point
Curve.
addition for when x1 does not equal x2. Okay, so this is like a pretty clear-cut case.
Mm.
This is slow. Oh, this is like slope and stuff.
Oh yeah, that's exactly where we stopped.
So we would need for what is the shift key on my keyboard broke. So there's gonna be some.
Like the left shift.
Yeah, the left shift.
Oh, that's crazy.
It's not
Go
fun.
there with you.
It is not fun. So 2, 5. And then what is our A and B? It would be 5 and 7, right?
All right, yeah, yeah. So, like explicitly put the point zero for all the numbers, so they're floats.
Right. Yep. Otherwise, we'd have to like cast them or whatever.
Mm-hmm. But not for A and B. A and B are just integers.
So what is the answer here? Because we will need that for our test. So let's go back and look. Well, I guess let's. All right. We want to know what P3 is. So we start with the fact that P1 and P2 has this formula. What is this?
That's the slope calculation.
Right. Yeah. So y squared equals man, this is the whole like creating the polynomial equations or whatever.
Yeah,
I remember going over this, but it's been a while.
you did. I went like halfway and then I just trusted, didn't verify all the way.
Yeah. Oh, because okay, so this is the x and y of the first slope is equal to what? Hold on. X1, x2. Okay, so the slope. So we find the slope first, I think, right?
Mm-hmm. Yeah, because we have all the data for the slope information.
All right. So find the slope. Which it gives us the calculation. So slope equals. So y2. So that's going to be other dot y minus self dot y, and then we're dividing that by other dot x minus self dot x, and that's this here, right? And so that should give us the slope.
Mm-hmm.
And then what is this y for though? Oh, that's the equation of the line. So
That would be like kind of like y3, I think. Yeah, you have y1, y2. This would be y3. It's just not noted.
Right.
Which I think is.
And this is going to be. So this is this like they took the slope formula, injected it here. Oh, because y equals that. So you're taking the formula, and then raising it to the second power. And because y to the
Mm-hmm.
second power is equal to the slope formula to the second power, which is equal to the elliptic curve equation,
Mm-hmm.
and then you do, oh man, this is, so the x to the third is just this. The minus s to the second times x to the second, I believe, is where you take this and
Like you're
apply it.
distributing the power, right?
Right. Plus a 2sx1. Oh, yeah, distributing the power would be just to this right here. So distribute the power to this right here first. That gives us, so distributing the power of 2 to s times x gives us this. And then distributing the power, I believe, to, well,
Mm,
this is weird.
minus, because yeah, before you distribute the power, you would multiply s times x and s times minus x1 to get rid of that first parenthesis first. Yeah, it is.
These outer ones you're saying?
The internal one first.
These ones.
Yeah, so you have sx minus sx1, right?
Yeah.
Yeah, it's just. I wish he took like a couple more rows. I think he
Yeah. This
like
is
kind of skips a few steps there.
one. It has to be. It has to do with the breaking down of like the polynomial equations or whatever,
Mm-hmm.
and how you're ultimately trying to get to zero.
Like you're moving everything to one side.
Right. Um, hmm. I'm just gonna believe.
Exactly. Just take
We
the
also know that
equations.
x, x2, x3 are solutions to this equation.
I didn't know that.
Yeah. Why are they solutions to the equation? Is that because... Oh, well, no. Why are they solutions to the equation? I'm trying to think of how... Is it because it's flipped over the x-axis?
I don't know, man. I thought the same thing. Like, where did this conclusion come from?
Yeah. Well, here's our lack of math education showing. And so because of this, this is... Oh, okay. That's x to the third. This is... When you combine these, it becomes x to the third minus x1, 2, 3 times x squared. Yeah, man, we need to revisit algebra and polynomial equations.
Yeah.
From earlier, we know. Vieta's formula. What is that? The coefficient have to equal each other if the roots are the same. The the first coefficient that interesting is a coefficient in front of x squared. So x squared is negative s2. Just a second. Oh, man. Okay. Well, this is the end of transmission, QED. Um, I think this is the formula we need.
Mm-hmm.
But how do we get? Wait, hold on. We can't. We don't have
We
x.
have y3. We have y3 from the previous. Like outside this box, we have had found y3 already. Right there.
But we need x3 first.
x3, I think we find at the end of this.
Well, no, x3 is right here. It's the slope squared minus x1 minus x2. Oh,
Oh,
so we
okay.
have everything that we need right here.
Oh, we do. Okay.
I believe
Ah, he's
so.
just explaining. Yeah. So Jimmy is just explaining how he got there.
Yeah, I believe so. That's still.
Yeah, I think that is the case.
Yeah, it's been a long time since I've had to do the whole like moving things from one side of the equal sign to the other.
Yeah.
Okay, so find the slope. Once we have the slope, then we can solve for x3. So let's see, what is let um, x3, I like that, solution x, and so this would be slope dot power 2 minus what is let's see here, power 2, x1 is self here. I've got a comment from a viewer saying that we reminded him that he's never going to be a coder because of polynomials, but I would say that he is smart enough to learn polynomials. So
Yes, you are.
because we don't know polynomials right here. I mean, we know them, but I learned them once, and then yeah. Anyway,
And in this case, yeah, we're not actively like once we code the operations, we're not going through the polynomials all the time.
right? Yeah.
Rarely.
That's true.
Yeah.
Yes. We are trusting and not verifying, which is probably the wrong answer. It's very high time preference, but
Mhm.
it's late, and we only do this for so long. So we're gonna have a little bit of high time preference with
Yes.
our polynomial math, and just trust that Jimmy Song knows what he's talking about.
We're gonna do a lot of testing before we commit our real Bitcoin.
There we go.
Right
I
before.
was I was thinking about that. I was thinking about like what do we do at the end of this, and I think what we do is we go on testnet and use our code to send transactions.
Mm-hmm. Yeah, our fresh new wallet,
Yeah.
our library.
Um, okay, so we have x3, which is the solution x, we're calling it, and
Mm-hmm.
then solve for y. So I really don't like the name solution, but it's solution x and solution y. That's what we're going with right now.
Okay.
And so this is going to be
Slope. No.
slope times
Self.x.
self.x minus other, or oops, no, that'd be solution x minus self.y. And now we have the, oh, now we have x and y. So we should
Mm-hmm.
be able to return,
Differentiate. Yeah.
except this time we have actual values to return. Oh, wait, remember that y, the answer y is the reflection over the x-axis. So does that mean that we inverse this whole equation then? Is that what he meant here? Yeah. Yeah, we inverse this whole thing.
Hmm.
Oh, I think
Something like
this is
that.
just that whole equation that we just typed, but different.
It's like substituting the slope,
Right, right, right.
replacing the slope, right? And might be.
So yeah, we negate it to flip it over the x-axis. So do we know what the answer is to this
Let me pull it up. So we.
now that we coded it?
Exercise 4, right?
Right.
Doesn't have the answer for this one.
It does not have the answer you said?
No, it doesn't. It has for 3 and 5.
Is this in the... I think they have
Maybe
answers in
that
the book.
Jupyter.
Hold on.
Yeah, take a look. Maybe it's only missing the Jupyter notebook.
Uh, Time to file a bug report.
Yes.
Finite fields. What chapter is this? 2?
Oh, actually, I'm here. I'm here. I found it. Did you get the curve? The point?
Exercise 4. Yeah, it's 3 and -7.
Mm-hmm.
Is that what it says? Is that what you got in the notebook?
Mm-hmm.
So let expected equal point and this is, I said 3 and -7. Right. And then this is still 5 and 7.
Same curve.
So we should get
Insert
P1 plus P2.
2 equals expected.
Right.
Oh, that's how it works. Okay, no equals. It's like 2 parameters for the assertion.
Oh, no, it's not. I'm sorry. There's,
Oh.
sometimes there are methods or macros where you can do assert equals.
Mm-hmm.
But that's not what we've been doing. It's just, this is like assert, like it should be true.
Okay.
Or it panics, I guess. Let's run the test. Figure out if this thing works or not. Uh-oh. Could not compile. Oh.
337.
Do you know what we need to do to fix this?
File function. I'm getting 337, but that's not 54. I get row 54. Let me see.
Yeah, and if you look, so look at what file, right? So look at the file that the compiler is yelling at you about. And so like this is like,
Rust.
yeah, this one's deep in the weeds of some, it's in the F64 definition of the standard library. And this is just saying, hey, this associated this function that's throwing this power f for a float, powf, like you can go look at the code if you wanted to, just to
Look at the source code of the language.
But our code is actually throwing the issue because we don't have
function.
Yeah.
The slope expected float 64. So just adding the 0.0 there would do it.
Yep. Exactly.
Of user flow literal 2.0. Okay.
Yep. Yeah, it tells you, the Rust compiler just tells you exactly what you want to do.
This is so nice. Okay.
We do have people in the chat in Twitch. We have 3 viewers. We have tripled our viewership. Yeah, hey Gary, it's nice of Rust to have specific tracebacks. Python just added this feature in 3.11. So have you, in the Python that you've been working with, Pleblaira, have you seen that, like the tracebacks or
I've
no?
been watching some videos about Python 3.11. Haven't installed it yet.
Okay.
I heard it's much faster. Like we were just talking about, like performance.
Oh yeah.
It says up like between 10 and 60% faster.
Wow. 60. I mean, 60%'s a lot. Um,
Tracebacks, yeah.
did you fix that? Did you put the 2.0 there on line 54?
Mm-hmm.
All right, cool. Let's run this again. See what we see. Fail. Fail. Something failed. Uh-oh. What is going on here? Assertion failed.
Was it? Yeah, this one.
Yeah, I thought it should. Actually, I think. Hold on. So let's actually use that assert equal, because I think it'll give us a prettier printout of like what's like what went what went wrong. I don't know why that was hard to
Mm-hmm.
say, but yeah, like I think it will give us what two values are being compared. Okay, what's going on here? Ah, okay. So it is, huh. I wonder if assert equals uses the debug. So this is another one of those traits. You know how we implemented copy and clone on Rust to
Mm-hmm.
allow the memory management to kind of happen automatically. Um,
Mm-hmm.
this one, okay, yeah. So this macro prints the values of the expressions with their debug representation. So that's what this debug trait is it allows for you to print out to like a console or print like a text version or a string version of whatever it is that you've like whatever object, and you can define that yourself, or the easiest way is we just add debug up here to our traits that we derive.
Mm-hmm.
But if you wanted to say create a custom way for debugging where you add some extra whatever, or maybe you didn't want to show the AB, or I don't know why you'd want to do number thing, you can customize like the debug display of something, or just debug it, or
Nice.
derive a trait from it. So
Mm-hmm.
now, there we go. So, oh, interesting. So we didn't need to. So this is showing on the right, expected, right?
Mm. Ah, right. That's what it means. But okay, left equals right. Interesting.
Well, it's more
Nice.
of, yeah, it just shows you left and right, which
Like the two parameters, it
exactly,
references them this way.
exactly,
Interesting.
which is kind of nice.
Yeah.
But yeah, so I mean, we got it wrong. So I guess we didn't have to invert that. Um,
Mm. So it gives you which parameters it's looking at. Nice debugging, yeah. So we didn't have to reinvert the whole line here.
right, right, right. We didn't have to flip it here.
Mm-hmm.
And I wonder if that's because we just, I think this is probably, I wonder if that's where we do it. Where does it get inverted in this whole thing? But we have to reflect so the right side has to be negated. Oh. When we were reading this, and I was like, oh, we need to negate this thing. It was actually saying like this is the correct answer here,
Mm.
which is what we have here now, if that makes sense.
Yeah.
And now if we run it, it works. Cool,
All
passed.
right.
Nice,
Fast. Amazing.
very nice.
So here we are adding 2 points on an elliptic curve that are not on a straight line. So they're
Well,
gonna
that
have
are not,
an
um,
intersection.
yeah,
Oh,
that
I'm
don't
sorry, yeah, not vertical, right? Yeah.
vertical line. Yes, vertical line. So same x values for each point. So if the same x values are for each point, then it's the identity point or the infinity point.
Mm-hmm.
But yeah, this is a addition of two that are not like not vertical, where the slope is
Yeah.
not vertical, I guess.
Slope. Yeah.
And then the last one is
The slope on a vertical line is zero, probably, right? Or one. That's a question.
yes, yeah, I don't.
It's a question for Solar Echo 3.
It
Is
is.
there?
Yeah, Solar Echo 3, do you know? What's the slope of a vertical line? Pop quiz. Um, now we can move on. Write the add method where x1 does not equal x2. Oh, we just did
Which I
that.
guess we just did,
Yeah,
right?
yeah.
Yeah.
So that's like 4 and 5, not plus 5. Cool.
Okay.
So
Point addition for when P1 equals P2.
are the same and the y coordinate is different. We have this situation where the points are opposite each other over the x-axis. We know that this means, right? Okay.
Okay, he's
The identity
preceding
point.
the
Yep.
question, like setting it up.
Yep. Yeah, we already did that part of it.
Same x, different y. Now the example is same x and same y. Basically same point. We're just summing it to itself.
What happened? Wait, what?
Yeah, now we're gonna add the same point to itself. Or yeah, P1 equals P2.
Right. Visual. Okay. Oh, yeah. Okay. Yes, that makes sense. Because if we're adding this point to this point, I think we get this point
Mm-hmm.
flipped, probably. Um, Solar Echo 3, by
Oh.
the way, is consulting the Oracle. I'm assuming that's the new OpenAI GPT-3 chat bot, but he might be consulting. Because there's no vertical change in rise over run being 0, it is trying to divide by 0, so the answer is null. We have null again.
That's our null.
That's our null. Well, okay.
Thank you, man.
Well, okay, no, that's interesting, right? Because we cannot divide by 0, rise over run, we cannot divide by 0, and so therefore it's the infinity point,
Mm-hmm.
right? Which is like the null point of like this whole math for elliptic curves. So that makes sense too, like the rise over run sort of thing. Can't divide by 0, you get a bad, you know.
You get infinity.
You
Or
get infinity,
no.
yeah, you get infinity.
Or in Rust you get infinity. Or in other languages you get null.
Nice. Okay. So this is adding to itself, which
Mm-hmm.
so let's create a test case for this thing.
Yeah.
So P1 will be, and I guess we could just, let's see what they use.
Mm.
Bum.
I think it was up there, no? -1? Yeah.
-1. Yep.
-1.0, yeah.
Yep. And then 5, 7.
Do the semicolon here.
Yep. Yeah, I wanted that semicolon. And so well, let's go through before we know what the. I guess we can look up what the answer is, and then we can code our test to have the answer. So it's 18 and 77.
As expected.
Right? Yeah. No. I
Why you did that? It's so obvious.
yeah. What was the numbers? 18 and 77.
And I can do here. Insert.
Nice. Yes, sir.
It's yelling here.
Why is it yelling?
In the previous one.
Unexpected end of macro.
Unexpected
Oh,
semicolon. This one?
yeah, yeah, yeah. We semicolons will get you.
Yeah.
Consulting the Oracle used to be Google. This is from Solar Echo 3. Consulting the Oracle used to be Google, but Chat GPT dropping a few days ago is already changing this. I wonder if Google is shaken. Bing is supposedly already looking to put Chat GPT into their engine. That wouldn't
Uh,
surprise me. I mean, like, have you played with the Chat GPT?
no, I'm only seeing the posts on Twitter.
I mean,
It's
it's very cool.
impressive.
You can like you can tell when you hit a limit, like of like it doesn't want to do the thing that you're asking it to do, sort of thing.
Mm.
But it's definitely very fun. I used it to help my wife with a writing prompt for her for her class that she's in. I was like, hey,
You
I want to
just
try
like gave
something.
the whole thing, like
No,
take
she
it.
didn't take the whole thing. So she's too honest to do that.
Hmm.
She's
But GPT like gave like a whole essay.
Yeah, she had to write something about like where correlation doesn't equal causation. So she like did it like 5 times. Like she gave the prompt to the GPT-3 like 5 times, and it just kind of like inspired her for like what she could write about because it was sort of like a
Nice.
writer's block thing that she was having where she's like, I can't think of something. And I was like, here,
Hmm.
go to this website, type it in there. And she's like, this is like
Yeah.
cheating. And I was like, no, it's not. Like don't copy and paste it. Like but this is helping you
Hmm.
move the ball forward.
Inspiration.
All right.
And I
Anyway,
saw some of the examples I saw posted like for the stuff that I know, like they were doing something with Python that I was familiar with.
oh yeah, yeah,
It,
yeah.
did, it didn't explain all the way. Like if you gave that to someone that didn't know Python, it's not like they became a programmer immediately.
Yeah.
You still, we still, yeah. It's not. Ah,
So we
this is
got
some bot or something.
oh somebody in bot
Yeah.
dogehype.com.
Speaking of Chat GPT,
Yeah.
there we go. Someone's
No.
probably using
So yeah, I'm not even gonna read your name. So that's cool, I guess. Thanks for watching though.
it. Yeah.
Blaker the Black Faker,
Yeah.
however you
Clearly.
want to say it. Um. All right, so let's code it up where the point is the same because apparently that
Okay.
is so the point is the same. So we're just finding the slope and then we're finding where that slope intersects because if the point addition is the same, there's only going to be one other point on that elliptic curve that intersects with a line at whatever slope it is. Um, I think we'll need to handle this though in a like an if statement. We'll have to like short circuit it, right? So like, um, so if self, right? Because I think we defined. Did we man, can't type. Really can't type. Did we define?
Like the equal
Yeah, did we
method.
defined equal, right? Yes, we did. Okay. So if they're equal, we'll do this thing.
Oh, yeah. That's easy. You don't even have to specify the x and the y. Like it's fully
No.
equal.
Yeah,
Wow.
yeah. Because we already defined that a and b have to be equal as well as x and y for
Hmm.
the point to equal another point.
Nice.
Um, so cool. Yeah, we find the point or the slope.
One more comment, real quick, about
Sure.
Chat GPT. I don't know if you're getting these ads on Twitter. This company now it's saying, "Oh, we're implementing Chat GPT in our coding platform, so you can code an app just by enunciating what it needs to do." I think they're a little ahead, you know. I want an app that it's an instant messenger with a lightning wallet. And then you think it's just gonna work. I think it's too soon.
It is, yeah. I've used GitHub Autopilot was another is like another AI
Hmm.
sort of driven code. It's specifically that AI specifically is geared towards software, right? Like it's from GitHub. So that was like that one's pretty cool. I've since stopped. I think it's out of free beta or something like that. But that was pretty cool. And you could even train it on your code base. Like if you're a big enterprise, you could
Mm.
train GitHub Autopilot on your code base to like make sure the styling stays the same and like just like whatever patterns or whatever you have, um, it can infer for you. So yeah, I don't know how that competes with this GPT-3 chat thing, um, but Either way, have you read Jeff Booth's The Price of Tomorrow?
Yes.
That's what I think about with all this AI stuff because he has a specific if he if it's a specific if there's a specific AI or I'm sorry, specific section in the book that he talks about AI and how it's deflationary and how basically like there's so many jobs that are just going to be replaced by AI because it's like AI is getting so robust. And the
Mhm.
more we do AI, the better it gets, and like eventually the AI is going to be making better AI than we can make, like sort of thing,
Oh
like
yeah.
that. The whole like singularity point type of thing, which is scary and mind blowing and exciting all at the same time.
Yeah. Once it's hit, it's like a few seconds, and it's everything is changed already.
Yeah, Copilot. I'm sorry, GitHub Copilot. Yeah, Solar
Copilot.
Echo 3 says in the chat if you've ever tried Copilot, I don't think it's ready. Um, and that was kind of the impression I got too, especially when it came to like a newer language. So like if you're writing JavaScript on the web for just like or React or like whatever web stuff or probably Python too, just because there's so much Python out there, it would probably
Mm.
do okay, right? Like you're probably fine. I started using it when it first came out, and I was writing Rust with this game engine called Bevy, which is in 0.9. Pretty cool game engine if you're into gaming, um, but it's all Rust. And because it was like such a new framework and new like Rust is a relatively new language comparatively to JavaScript and Python, that like the amount of code in Python and JavaScript out there to be trained on is like vast, where Rust is
Mm.
a little bit smaller of a volume. It's growing, I believe, but anyway, the AI couldn't figure out what I wanted to do, and it was just outright wrong, especially because the framework was in early alpha stages of like they made drastic changes to how the code was written, and how you kind of wrote code within the framework. So anyway, we're here to talk about programming Bitcoin and Rust. We have 2 points.
I guess the main point, sorry, is that there's gonna be plenty of work for humans still
Oh
for
yeah,
plenty of
yeah.
time. Yeah.
I still think the high level architectural design is going to be very relevant for a long time.
Yeah.
Like we'll be able to tell the robots like, hey, write me a message queue for in Java or something, and they'll do it. But um,
But yeah, that's pretty much it.
yeah, we'll get there, all in due time.
Hmm. Yeah.
But if you have 2 points that are the same point on an elliptic curve, how do we add them? We need a slope. And how do we get the slope?
It's basically the same equations, but you just yeah whatever x2 and y2 you turn them into x1 y1
Like
or
this
you
same
know what I mean.
equation, but
I think
it's
so, no?
I think
Yeah.
it's different because they're the same
Mm.
point. If we did this, it would just be 0 divided by 0.
Ah, yeah, good point.
So there is a different. Oh, because
Ah,
we
there's
only have. Okay, so P1 plus P1 equals P3. That's a tangent point. This one. What is the? Let's see. There was. This is the slope. Um, the slope of a line. Why is this the slope of the line? Deriving. Oh, here we go. Using some slightly more calculus. Okay,
mhm.
so if we couldn't get polynomials, um, there's a good chance that we're not going to understand the calculus. But for posterity's sake, let's try to dissect this thing. We know the slope at a given
Derivatives, yeah.
is dy and dx. To get this, we need to take the derivatives of both sides of the elliptic curve equation. Taking the derivatives of both sides. Why is this the derivative? What makes this the derivative?
I don't know. Now I'm thinking
I
FTX,
never got to. What's that?
perps, and I'm thinking all this derivative trading junk.
Oh, yeah.
The other derivative.
Yeah, I do not know. I never took calculus, so
Me neither. Yeah.
I'm not sure what this is, and so I think we're going to have to. we are going to have to trust here
Yeah.
without verifying. Just because I don't have time to learn calculus tonight. I don't know about you.
No, I'm good. I don't think we'll have time for that.
The rest of the results from the point addition. I mean, I imagine the derivative. I mean, because the curve is defined, right? Like, so the elliptic curve itself is defined, and so because that is defined, we know, like, we should know that a point, like how to find points on that, I guess. And I'm assuming maybe that's how the calculus part of it works.
Mm.
Um,
Yeah, I guess we can just use that slope equation that's given to us.
yeah, I'm trying to reason about like the calculus of it, right? Like, we have these two same points, but because this like the line itself is a predictable thing, it makes
Mm-hmm.
sense that we should be able to derive a slope that like intersects it. I'm just not
It
sure.
doesn't touch the curve anywhere else, right? That's kind of
Right, right,
where
right,
the
right.
limit
Yeah,
and
yeah,
the
yeah, yeah.
derivatives come from.
That makes sense.
There's only one slope that will not touch on either side of the curve.
Right. So we've got, let's see here, we've got 3, which we need to do floats, times, so self dot x to the power of 2, and we're plus a. So self dot a. I was like, where do we get a from? We haven't used the actual
Yeah.
what is that called? The a and b part of it. I don't remember. Do you remember
Is
what
there
that's called?
a name for the A and B?
I thought there was a name for the a and b. I mean, I guess it's just the curve of the equation. Like, it defines the curve.
Yeah, I
Like
don't think we have
that's
a
what
name
defines
for
the
it.
curve. So I don't remember the name for that, but all right. So we got this. We've got 3 times x squared plus a, and then we divide all of that by 2 times self dot y, and there's no exponent for the y.
I don't think we had a name for A and B. Just I was curious. I skimmed here. I don't think what we found. Right
I mean, yeah, I feel like it's safe to just say it's the it defines the elliptic curve that we're working with.
on. Mm-hmm. Yes.
So what is this? 3. I think we need parentheses here. Oh, wait, is okay. So we've got to remember our a.
Mm-hmm.
We made
Uh-huh.
a an I8 because we knew, at least for Bitcoin purposes, a was going to be 0 and b is going to be 7.
So we don't need more than an I8 for that.
But when we're doing the maths, we have
Mm-hmm.
to let Russ know that, like, hey, we want this to be a float 64.
So here you're casting A as a float 64.
Right, and I think we did this previously somewhere else,
Mm-hmm.
um, but it's because we know that, like, this is okay. It might be a little dangerous to do if it was some other type, um, but because it's an what is it, I8? Like, an I8 is definitely going to fit into the memory allocation space of a float 64. Like, a float
Mm.
64 is so much bigger than an integer 8.
The opposite is what could be risky.
Right,
Would
right.
certainly fail.
Correct. Well, it wouldn't certainly fail, because if you had 1.0,
Mm.
as a value in float
Yeah,
64, you could cast that as an I8.
which
But
we did. Yeah, minus
you know,
minus one also fits in I8.
right.
Yeah.
And I think there are helper methods that can help you sort of like um, try methods. I think is usually the nomenclature that they use.
Mm-hmm.
Um, but
Yeah.
we have our slope now.
Okay.
Goes through as before.
So here's where it's combined. Okay.
Right, right, right. Okay, so it looks. Hold on. We can do. I think. I think. I think we do something like this because it's either the. Oh man, my broken keyboard. Um, I think we can do something like this because it's either going to be the same point or it's not. But then um, the the calculation is the same. The rest of the formula goes through as before. So
Mm.
Jimmy combines them here, which is fine, but we don't need to necessarily,
Ah,
right?
nice. Yeah, yeah.
Like I don't think we
Oh,
do.
that's. And this is at the end of the class, so all the other cases will have been addressed by then.
Right. And we need to define slope as mutable because we are going to be changing it after it's defined. Um,
Mm-hmm.
and we can just, I mean, we can probably just set it to 0 initially because well, let's see, what is it yelling at? Slope is never red. That is. Oh no, I think we can just hold on. This is where. I think we can do this. What does this complain about? Unnecessary. Oh, unnecessary parentheses. It doesn't like our parentheses. Okay. There we go. Okay, so there we go. So we don't need to define it as mutable because we're not changing it. We're just assigning to it, and we're only assigning it to it one time, and it's based on a conditional. So it's either going to be one or the other. So the compiler knows
Mm.
that, right? Like it
Nice.
can recognize that that's a thing. Um,
Mm-hmm.
so I think.
That's cool. I like what you did.
What do you mean?
Very clever. Yeah, you don't have to redo the two last
Oh,
lines.
yeah, yeah. Well, a good engineer is a lazy engineer because you never want to do the same thing twice.
Uh,
Um, so, or at least that's something that I've heard before. Um,
we
yeah,
can run
okay.
our tests now.
Yeah, 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 yeah. Hey, it worked. That's awesome.
Minus one, minus one. Can you scroll up to the curve, like to the visual of the curve on the actual PDF? Yeah. So minus one. Where would that be?
So -1, right? So it'd
Uh-huh.
be -1 and then -1. Would be like down
I,
here.
yeah, maybe this curve isn't, you know,
This might
accurate.
not be the 5-7 curve.
Mm-hmm.
Um, which I think we check that, right? Like, yeah, yeah, we check to make sure that like when we create a new point, we check to make sure that those points are on the curve. So yeah,
Mm-hmm.
this is probably not the 5-7 curve then.
Yeah. You want to draw it on that website?
What website?
I'm
Yeah, sure.
curious to see this line. Desmos, right? Desmos.com.
D.
desmos.com/calculator.
Ooh, excuse me.
Curious to see this line.
So y
Y squared.
squared equals x x squared, right? Or is it just...
Oh,
No, I think it's just x times a,
no. Oh, yeah.
which
Yeah,
a
plus
would be
b.
5.
So 5x plus 5x, that's it. No. Or x plus 7.
Yeah.
Oh, oh, that's okay.
There we go. Yeah. So that's,
We have the -1 here.
yeah, -1.
Oh, yeah. Nice.
Huh.
So then if you draw a line,
What
how
is
do
it?
you draw this line now?
18 and 77? Yeah, I don't, how do you draw a line?
It's like epsilon y equals x plus something, right? It's basically that. It's a linear. A line is linear, so
Well, it's on the
yeah.
positive side, right? Like it's so it's at
If you
8.
calculate the slope, how much is the slope for this line?
Wow. This I'm sorry. How much is the slope for this line?
Yeah, because I don't know if that would help.
Um yeah, I don't know.
Yeah, maybe
Let's
it's too far away.
So to calculate the slope, we can go back. We just calculated the slope.
Yeah,
Where
we
is
had
it?
a formula for the slope.
Yeah, yeah. So if it's the same, it's going to be this. um,
This-
so we can pull up a calculator.
oh yeah.
So 3 times. So in this case, x is going to be -1 to the second power plus plus 5, which is a, divided by 2 times 7?
Or a -1. I would
What?
self dot y.
Yeah, it would be 7, right? Yeah. Oh, I'm sorry.
No,
You're right.
it's -1.
You are so right. Oh no. Okay, phew, we saved it. 2 times -1. So -2 is the
Slope.
slope. So I mean, how do you
Draw a line.
draw a line with slope of -2?
You have chat GPT there?
Yeah, we could, but so the formula is y equals mx plus b. I don't remember what m and b stand for.
Yeah. Shit. Anyone in the chat knows how to draw a line with the slope? Or we have the slope. We have one of the points.
Right.
And we draw the line.
Let's ask the AI.
Yeah.
See if this should work.
Rise over run plus y intercept. Solar Echo helped us.
Rise over run plus y intercept. So the rise is going to be,
-2. No, run is -2.
what is the y intercept? That's where it crosses the y, right? Like where it crosses the y axis? I believe. So negative 2.646.
Oh man.
So y equals, so rise over run. So, yeah, solar echo, man, I don't know. It's been a long time. It's been a long time. What is the slope formula for, what is the formula for a line with slope -2 that has a point of, what was that point we did?
So -1.
Oh, here, hold on. He's got it. He's got it in the chat. It's y equals -2, okay, over 1 plus where it crosses the y, and that's that negative 2.646.
We need some kind of multiplication.
Yeah, I think so. Oh, I think we multiply this. Yeah, there it is. We have to multiply by x.
Hmm.
Right, because it's, yeah, it's that, okay. Oh, that's the m and b. The m is the rise over run. The b is the y-intercept. Y equals mx plus b.
Y equals mx plus b.
Yeah, man, it's going back to high school, high school algebra and geometry.
But you see, there's something that needs to, if we want to find the example that we just did on Rust here,
Right.
the point isn't -1. -1 is a little above it, like where it intersects it.
Yeah, you're right. What are we missing here? I wonder if this point we have is incorrect.
It might be it.
Yeah, where the y-intercept is. Because I don't think the y. Okay, so yeah, I don't. So the y-intercept would. Yes. So the y-intercept is not going to be a point
It would be
on
like on the actual curve.
the actual curve. So I think what we need to do is figure out what the difference is between the intersecting point and -1.
Mm.
Welcome to the chat, Wyo Hodl. Hodl.
Psychology degree for the win.
Yeah.
Music degree here. So we're in this together.
I've got an associate's degree in Chinese Mandarin, if that counts for anything. So I think
Fields here of expertise.
yeah, we are wide and diverse, but that's Bitcoin. So okay, so I think if we find the difference between -1 and this, so that would be what,
545.
So excuse me, it'd be 555, right?
545. Like 0.5.
I'm sorry.
545, yeah. 0.545 to make it -1.
Yeah. So we need to move the y-intercept by that much.
Oh wow.
Or maybe not. Maybe we moved it too far.
No?
No, because now we're not
Ah.
we're still off by a little bit.
You drew the tangent there.
I mean, yeah, we do have a tangent line here.
It's not exactly on that point that we were looking for.
No, so how would we get to? I wonder how we get to the -1. So we need this point to shift. Ah, I think it's. I think it's because we shifted. Okay, all right, I know what it is. let's get back. Okay, so we have this point of intersection here somewhere. Oh, no, it's like slightly off. I think we also need to add the difference to x, that this varies from -1 as well, right? Because it's -1x and -1y is the point on there. So we actually need to subtract 0.0956 from x. And I think that will... What did I say? Crap. 0.0956. No, that didn't work either.
You know what I just did?
What's up?
I don't know if that worked, but click on the red curve, the y squared curve, and you can add a slider for the. Actually, yeah, draw a new curve, and then just do the y equals mx plus b. Or yeah, go ahead with what you're doing.
What? Okay, say again.
Start a new curve, like number 3, and then just draw y equals mx plus b. And it lets you add the sliders. Check this out.
What should I kick? What should I click?
Do all.
Oh.
Yeah, either way. And then you can.
Oh.
Yeah.
So now if we put -2,
which is our slope.
Ah, ha ha ha.
We can like brute force it.
Yeah, it's -3. Because we're at negative, well, is that negative? Yeah, so -1, -1. Now that doesn't...
It's not tangent.
Yeah, that's intersecting at 2 points on the line. But it says, according to...
Maybe our slope has to be a little more. Not quite 2.
Yeah, maybe it's not -2.
Yeah, not -2. Sorry, I totally threw a wrench in you.
No, you're fine. This is, we're here to learn.
Try something then. Try m equals -3.5.
3.5?
For m.
Oh, 3.5, okay.
And then -4.5 for b.
That looks like... Where'd you get that from?
I was just guessing.
Are you serious?
Yeah, no, like I was just with the slider, like going back.
Oh, okay, yeah. Yeah, that looks to be right. So -1.
And it should meet at the -77, right?
Right. Yeah, all the way down here. It doesn't.
So yeah, probably just needs 3.62 or something like that.
Huh. Yeah, we're trying to do calculus, I guess, with this, so...
Yeah.
I'm not sure.
Yeah, so this is kind of like, I guess, what the derivatives and the limits would be for.
I assume so, yeah, and it's probably a lot more decimal, like places after the decimal point, if I had to guess.
Yeah. Cool. Okay.
Well, that was a fun tangent.
Yeah. Literally. No
Yeah.
pun intended.
Hey. Who
Nice.
says math isn't fun?
Yes. The last exception.
Yep. All right. Let's see what this is about. Vertical and tangent to the curve.
So P1 equals P2,
Yep.
but the sum is identity point.
So if self equals other and the y coordinate is
Y equals 0. You have to both confirm if they're equal to 0. No, if one is
I don't
0,
think
the other
so.
one has
Yeah.
to be 0.
Yeah, because they're equal, yeah. So they're equal and they both have y as 0.
Because they're going to be right where the curve mirrors, which is right at x equals 0.
And then we just return the infinity point. Which, if we're returning the infinity point, we could. Why is this? So, and self y equals 0 times self x? I wonder why they multiply the x by 0. Anything times 0 is 0, though, right?
Mm-hmm. I think I was looking into the repo for something else, and I found someone kind of like guessing why they had self.x there, like 0 times self.x. It was like to protect against an exception that can happen at some point.
Oh, that might. Yeah, I guess it could be a Python thing.
It might be, yeah.
So one of the things we can do is, because we already have an if branch that sort of returns uh, a infinity point, or the identity point rather, we can just kind of like piggyback off of that and put this here.
Being lazy, I see.
Right. Yes. Being lazy is good. So now it's if I can't. What is this one? If the y. Oh, this is the inverse one or whatever. Where it's a straight vertical line. So that makes sense too, because this is just a different version of the straight vertical line, except now if they're equal to each other and it's the y.
Oh yeah, because you're adding the two y's and they're equal to 0. Yeah.
Yeah. Okay.
Which I don't know.
What
It seems to me like you don't even have to code this
second
last
part of it?
exception, right? 'Cause if you add 0 plus 0, it's gonna get to 0. But maybe there are some exceptions that this would cover.
That's true.
Yeah. Well, it's there.
Yeah, it is there. I know. I get what you're saying though. Yeah, that's a good point.
Mm-hmm.
I guess the only way would be to write a test for it, but that's it. We finished a chapter. Chapter 2 is in the books.
Nice.
Yeah.
We don't have to code a quick test for this one. It's 10 o'clock, right? Maybe we know it's gonna work.
Yeah. Because it is not logically, it's not different than this.
Exactly. Yeah.
Because 0 plus 0 equals 0, and if self equals other, then self x also equals other x. So that should just work.
Yeah. All right.
Nice. Let's clean up some of this. I think, yeah, we got clean up some of these comments. And
How about for next week, we try to draw that curve, that the line actually that it's the perfect tangent to -1 and meets at -77. Like as a homework for the next time we meet.
I would rather do it on the Bitcoin curve, the SCCP 256K.
Nice. Okay. Yeah. Yeah.
Um,
Put some real numbers into that curve.
yeah, but well, hmm, I'm not
Yeah.
sure. Hold on, let's see. So Solar Echo has it could be because zero times an object yields a none type instead of divided by zero. Okay, so I think that's a Pythonism.
Hmm.
Um,
That's the because it multiplies by self dot x.
right, yeah, the self that x times zero.
On that. Okay.
The Yeah, I don't honestly. I'm not too keen on the whole like doing the tangent line thing, just because
Yeah.
I'm not
Yeah.
sure how
That's
much value it would be.
exactly. Yeah. Forget about it. Solar, are you on Twitter?
It's a good
If you
question.
are, yeah, share your handle. Let's connect.
Yeah, I have a feeling that I know Solar. I feel like I've shaken Solar's hand. If who Solar is who I think they are, if that makes sense.
Okay.
Because I had a couple people that were like, "Yeah, I'll come check it out." So I'm glad they did. Wyo Huddle, one of them. Shout out to Wyo Huddle. Thank you for tuning in.
Auto.
Um,
We have all the autos per state. Right? We had Florida BTC. We had Arizona and
yeah,
Colorado, Wyo Huddle. I like that.
maybe I should create a NIM Virginia Huddle that I just now like if it comes about. Obviously,
Yeah.
it's got to be me.
See if it's
See if it's
the
taken.
handles available. That's gonna be a rush to get that handle. Everybody like
Yeah, all three viewers. I don't think any of them
Virginia Huddle.
live in Virginia either. So,
That's
and then I can be real. Ah, there he is. Who is Scott Jackson? He's in Fairfax. Listen, I might have found somebody that is gonna come to my
ah,
meetup.
there you go. Is he active? August, yeah, not too long ago.
Yeah.
I'll look you up, Solar.
All right. Notorious W Pig. All right. Yep. I'm confirmed. Know who that is. Well, awesome. Hey, thanks to Wild Huddle and Solar Echo in the crowd. Thanks to anybody that's watching this in the future on YouTube. I will have this up on YouTube and have it up on Rumble as well. And yeah, we'll see everybody um, next Monday at 8:30, providing there are no issues. Thanks again
Sounds
to
good.
Pleb Lira.
Thanks, Gary. It was a pleasure as always, and see you again next week.
Yeah, man. Stay humble and stack sats.
Stacks ads.